Yes. So we solved half of the question in the last class, and now we have to simply determine the value of x. So how can we find the value of x now? The value of x, it actually represents the ratio of moles of water to moles of calcium nitrate. So it actually gives you the ratio between the moles of water and the moles of calcium nitrate, like between the moles of water and the moles of, you can say, the salt which will be given to you, any salt. It it's always the ratio between these two things. So to find x, what we will do, we will simply find the ratio of moles of water, H2O, divided by moles of the salt which will be given in the question. So moles of water, they were already given in the question, and 0.06, 0.0600, and we calculated the moles of salt and they were 0.0150, 0.0150, and when we divide them, we get x is equals to 4. So it would be 4. The value for x, it would be 4. It means that calcium nitrate, it consists of 4 water molecules. Is it clear?
Yes, Miss, it's clear.
Okay. Then you're given that nitrates that decompose on heating. Write the chemical equation for the reaction when solid sodium nitrate is heated. You have to write the chemical equation for it.
Uh, when sodium nitrate is heated,
Yes.
it will
What's the chemical
be
formula for sodium nitrate?
it will, in 3.
NaNO3. Yes, very good. It's NaNO3. Yes. What happens when solid sodium nitrate is heated?
It will be like breaks down, so like the nitrate ion will lose oxygen.
So that,
The nitrate ion will lose the oxygen.
yes, very good. It actually undergoes a decomposition reaction.
Decomposition.
Yes. So what would be the products?
NaNO2 plus O2.
Very good, excellent.
Hmm.
So when we have sodium nitrate, it gets broken down into sodium nitrite and oxygen gas. This is sodium nitrate, which is NaNO3, and when we heat it, it gets converted into NO2, which is sodium nitrite and oxygen will be released. Is it a balanced equation?
No, not really. No, there will be two, two, two two sodium
Two
nitrate
sodium
and then two sodium nitrate and the
nitrite.
solids nitrate
Yes, and what about the state symbols?
will be solid gas.
Very good. It's solid, solid and gas. Which type of reaction is this?
Thermal decomposition.
Very good, excellent. This is a thermal decomposition. Okay. Just a minute. Okay, so like, would you like to discuss the MCQs or the subjective part?
I would do MCQs because I get a bit confused here. Like,
Okay, that's fine. Mm, okay, so these are about the preparation of salts. Okay, so we are given that group 1 metals form compounds with group 7 halogens. The compounds formed are dash in water and contain dash bonds. Which words correctly complete the gaps 1 and 2? The compounds formed are dash. Are they soluble or insoluble? We have two options for gap 1. Group 1 metals, they form the compounds with group 7 halogens. The compounds formed are soluble or insoluble.
so the compounds formed will
Yes.
be like
Group 1 metals
it will
include.
be soluble. The
Very
compounds are
good.
soluble in water and contain ionic
Very good. And contain which type of bonding?
ionic.
Group 1 contain metals and group 7 contains non-metals.
So
So which
D,
bonding actually exists between them? Between metals and
D,
non-metals?
D.
Very good. It's soluble and ionic. Yes. D. Okay, which pair of substances can be used to prepare a sample of lead chloride when added to water and mixed? Which pair of substances can be used to prepare a sample of lead chloride?
Which is contain water mix.
Is lead chloride soluble or insoluble?
Lead chloride is insoluble.
Very good. So which of these pairs gives us lead chloride?
Lead to nitrate and sodium chloride.
Lead to nitrate and sodium chloride. Very good, excellent. It's option B. Why not option A?
Minus,
Why
sorry.
not lead? Why not option A? Lead and sodium chloride.
Because like the lead metal does not react with sodium chloride solution. Lead.
Very good, excellent. Very good. And why not C? Lead carbonate and sodium chloride.
Lead carbonate and sodium chloride. It's
Yes,
because like the lead carbonate is insoluble in water.
very good. Because to create the lead chloride, we need to mix two soluble salts solutions together.
Okay.
We get an insoluble salt from two soluble salts, right? But lead carbonate, it is insoluble in water. And what about option D? Lead and hydrochloric acid.
Lead and hydrochloric acid. It's
Yes.
because like lead is low reactivity metal, so it will like
Uh,
react very slow with hydrochloric acid.
yes. The reason is the same that we discussed before. Like lead reacts very slowly because a coating of insoluble lead chloride will form on the metal and it will stop the reaction. So option B is the correct option. Lead nitrate and sodium chloride, they are both soluble. And when they mix together, which type of reaction takes place to give us lead chloride?
And that is
Yes, which type of reaction takes place?
Could you scroll down the options?
The
I,
options?
I can't see the options because.
No, like I am asking you it on my own. This is not written on the screen
Oh,
anywhere.
okay. There is a
Yeah, I'm just
confused.
saying that lead nitrate and sodium chloride, they are both soluble salts. And when we mix them, we get lead chloride, right?
Yes,
So when we mix them, which type of reaction does take place that give you lead chloride? Which type of reaction?
like that nitrate. The reaction is like displacement reaction,
Very good. It's a double displacement reaction. Very good.
double displacement.
Okay. The table it shows the result of two reactions of an aqueous solution of a salt. Reagents are excess aqueous sodium hydroxide, and observation is white precipitate, and the second one is dilute nitric acid and aqueous silver nitrate, and the observation is yellow precipitate. What is the name of the salt?
Um, mm,
Using the first row, like the reagent where it's excess aqueous sodium hydroxide and the observation is white precipitate, what can we identify using this information?
we can. It can be. Let's
You can
see.
identify the
Yes.
cation that will be present in the salt, right?
Oh,
So
yes.
which cations can react with sodium hydroxide?
Sodium.
What about calcium ions?
Calcium.
If I
Um,
have calcium ions, will they
yes.
react with sodium hydroxide?
It will like. Will like calcium react? Yes.
Yes, calcium ions they react with sodium hydroxide and they gives us a white precipitate of calcium hydroxide.
Yes.
What others? What other possibilities do we have other than calcium?
Mm,
What about
can it
zinc
be?
ions?
Yes. Zinc
Zinc,
ions can also like. Yeah.
yes, zinc ions they can also react with sodium hydroxide and they also form a white precipitate of zinc hydroxide. So which one will be the correct option? Calcium ions or the zinc ions?
It will be.
Yes.
Mm, calcium
What's the reason?
because like from the sodium hydroxide it cannot like dissolve in excess.
Very good, excellent. Because calcium hydroxide it does not dissolve; it remains even when excess sodium hydroxide is added. And as far as the zinc hydroxide is concerned, it is amphoteric in nature and it dissolves in excess sodium hydroxide to form a colorless solution. So the cation must be a calcium cation because we are observing a white precipitate. So we should have that precipitate which does not get dissolved in excess of sodium hydroxide. So the cation must be a calcium Ca2 plus. And what about the anions? Now, if we want to identify the anions, we are given the options. As far as the cations were concerned, we can see in the options that we had only two possibilities. The first one was calcium and the other one was zinc. How can we now identify the anions, the negative ions?
We can like
We are given the second result that dilute nitric acid and aqueous silver nitrate gives us yellow precipitate.
oh okay. Uh, the iodide,
Iodide, very good, excellent. And how do we know that?
like like iodide is yellow precipitate.
Very good. Iodide ions, they forms a yellow precipitate. What about chloride ions?
They form chloride. They form white.
Very good. Chloride, they form white. Okay. What about um iodide? They are yellow.
Iodide. Yes.
What about bromide?
Bromide is green.
It's green or cream?
Cream.
Yes, it's cream. Very good. Okay, so the correct option would be option B. It's calcium iodide. Which substance? It's insoluble in water. Ammonium carbonate, ammonium nitrate, calcium carbonate, or calcium nitrate.
Which is insoluble.
Which of these is insoluble in water?
It is
And ammonium nitrate, are they
is it
soluble or
it's
insoluble?
calcium carbonate?
Very good. It's calcium carbonate. Why not A and B? Because all the ammonium salts they are soluble. And why not D?
Because the nitrate, all nitrate.
Salts are also soluble in water. Very good. And what about carbonates? Are all the carbonates insoluble?
No,
No.
no, not all.
What are the exceptions?
Sodium, potassium, and ammonium.
Very good. Most of the carbonates they are insoluble except for the ones that belong to that contain the group 1 elements like sodium or potassium. Okay, very good. Which process is used in the preparation of soluble salts? Electrolysis, evaporation, melting, or precipitation?
Evaporation.
Yes, very good. It's evaporation. Okay, then we are given ethyl amine gas and hydrogen chloride gas. They react together to form a white solid, ethylamine hydrochloride. At which position in the tube would a ring of solid white ethylamine hydrochloride form? A, B, C, or D? You are given the options as positions. Cotton wool soaked in ethylamine solution and cotton wool soaked in hydrochloric acid.
Mm,
This one is, I guess, also not a part of your syllabus. Like, have you learned the Gram's law of diffusion?
no, no.
So, yes, this is not a part of our syllabus. So, what is the correct sequence of for obtaining the pure salt from a mixture of sand and salt? How can we obtain the
Obtain
pure
pure
salt?
salt.
Yes,
We add like water, filter, and then evaporate it.
very good.
Mm,
So, it's option C.
mm.
Okay, so to which substance is dilute sulfuric acid added to prepare the lead sulfate?
Diluted acid.
Added to prepare lead sulfate.
Well, lead to sulfate. Mhm. Aqueous led to nitrate.
Aqueous led to nitrate. Option A. Very good, excellent. The table shows the solubility of some common compounds of metal Q in cold water. The carbonate salt of that metal Q, it is insoluble in cold water. The chloride salt of that metal Q, it is soluble in cold water. The sulfate salt of that metal Q, it is also insoluble in cold water. What is that metal Q? Is it barium, lead, magnesium, or sodium? You can evaluate the options one by one. What about barium carbonate? When if the metal is, let's say, barium, is barium carbonate insoluble?
Barium. I was muted. I was saying the answer is barium.
Yes, very good. Because barium carbonate it's insoluble, barium chloride is soluble, and barium sulfate is also insoluble.
Insoluble.
What about lead? Is
Lead
lead
is
carbonate insoluble?
lead carbonate is insoluble.
Very good. What about lead chloride?
It's insoluble.
Very good. So it's not correct according to the table.
Yeah.
Okay, moving to magnesium. Is magnesium carbonate insoluble?
Magnesium is insoluble. Yes.
Magnesium chloride?
Chloride is soluble.
Very good. What about magnesium sulfate?
Magnesium sulfate is soluble.
Very good, excellent. So this cannot be the option. And what about sodium?
Sodium carbonate is soluble.
Yes,
And then the chloride is chloride is also soluble.
yes. What about sulfate?
Sulfate is also soluble.
Yes, all common sodium salts they are soluble. Okay. Then we are given an aqueous solution of a compound X. It reacts with the aqueous zinc chloride to form a white precipitate which dissolves when X is in excess, and aluminum sulfate solution to form a white precipitate which is insoluble when X is in excess. What is the identity of X? Ammonia, barium chloride, silver nitrate, or sodium hydroxide?
Identity of X is
X reacts with aqueous zinc chloride to form a white precipitate which dissolves when X is in excess.
it ammonia is it A ammonia?
Option A, ammonia. Very good. What's very good, excellent. And what's the reason? Like,
Because uh,
yes,
zinc forms like white precipitate that dissolves in excess with ammonia.
okay,
And then the white, like it is like insoluble.
yes,
Then excess ammonia.
okay, very good, excellent. It's ammonia. Option A. Which reagent is added to aqueous potassium chloride to prepare lead chloride?
Then, lead chloride. Uh, aqueous lead nitrate.
Which one?
A. Aqueous lead nitrate.
Very good. And why are option B, C, and D not correct?
Because they're all insoluble and they do not work with precipitation.
Very good, excellent. Which compound is insoluble in water? Lead sulfate, silver nitrate, sodium carbonate, or zinc chloride? Which of them is insoluble in water?
Lead nitrate. I mean lead sulfate.
Yes, it's lead sulfate. Very good. Silver nitrate, is it soluble? Yes,
Silver
because
nitrate is soluble. Yes.
all nitrates
Nitrate
are
is
soluble.
soluble.
What about sodium carbonate?
Yes.
Why is it soluble? Are all the carbonates soluble? No. Then
No.
why is this soluble?
Because group one metal.
Yes, very good. It consists of a group 1 metal. What about zinc chloride?
Zinc chloride is soluble.
Are all the chlorides soluble?
No.
What are the exceptions?
Silver
Yes,
and lead chloride.
very good. Very good. Excellent. Silver and lead are the exceptions. Other than this, all the chlorides are soluble. Okay, then we are given that salts containing which of the following anions are always soluble in water? Carbonates, chlorides, nitrates, or sulfates?
Always soluble in water.
Yes,
Of the nitrates.
very good. Excellent. It's all the nitrates. In others, we have exceptions, but nitrates are all soluble. Which acid and base react together to produce an insoluble salt?
Acid and base
Hydrochloric acid and sodium hydroxide, nitric acid and calcium oxide, sulfuric acid and barium hydroxide, or sulfuric acid and zinc oxide.
the C. Sulfuric acid and barium. No. Yes, sulfuric acid and barium hydroxide.
Very good, excellent. Which salt will we get when we react sulfuric acid and barium hydroxide?
Okay, barium sulfate.
Very good, which is insoluble. What will we get when we react hydrochloric acid and sodium hydroxide?
You get sodium chloride.
Very good, and it's highly soluble. What do
Hmm.
we get when we react nitric acid and calcium oxide?
Calcium nitrate.
Very good, excellent. And we know that all the nitrates are soluble, so it will also give you a soluble salt. What do we get when we react sulfuric acid and zinc oxide?
Zinc sulfate.
Very good. And zinc sulfate, it is also a soluble salt. So the correct option is option C. Okay. Then we are given that which substance would not be used for preparing a pure sample of crystalline magnesium sulfate by reaction with dilute sulfuric acid? Magnesium carbonate, magnesium hydroxide, magnesium nitrate, or magnesium oxide would not be used for preparing a pure sample of crystalline magnesium sulfate by reaction with dilute sulfuric acid.
Not prepared for proof. It is magnesium nitrate.
Option C. Very
Yeah.
good, excellent. It's magnesium nitrate. And what is the reason?
Because because you like to prepare a pure sample of the salt, like the like soluble salt,
Yes,
you react an acid with a solid base.
very good. Okay, so it's option C. Then we are
Mm.
given which pair of the compounds could be used in the preparation of calcium sulfate.
Mm,
Calcium carbonate. And sodium sulfate, calcium chloride, and ammonium sulfate, calcium hydroxide and barium sulfate, and calcium nitrate and lead sulfate.
Is it calcium chloride and ammonium sulfate?
Very good, excellent. It's calcium chloride and ammonium sulfate. And why are other options not correct? A,
Because
C,
they are like
D.
calcium carbonate, calcium is carbonate is like insoluble, so insoluble.
Very, very
And for
good,
B, calcium chloride is like an ammonium sulfate. It's like they all are soluble.
very good,
And then C is like the barium sulfate is insoluble.
very good.
And
Calcium
for
sulfate. Yes, we know that calcium sulfate is an insoluble salt, and to prepare an insoluble salt, we require two soluble salt solutions. But in all the other three options, one of the compound it is insoluble. Only option B is the correct option, which contains both the soluble compounds or the soluble solutions. Okay, then we are given that a student mixed together aqueous solutions of Y and C, a white precipitate formed, which could not be solutions Y and C. Solution Y, which could not be solutions Y and C. Solution Y is hydrochloric acid and sodium chloride, and Z is silver nitrate, sodium nitrate, lead nitrate, and silver nitrate again. A student mixed together the aqueous solutions of Y and C, a white precipitate formed. So we actually want to see, what do we want to see? That by reacting each pair, which pair will not give you a white precipitate?
it
Which
will be
would not be the solution Y and C? So we simply want to see that which pair won't give you a white precipitate.
white precipitate. Okay.
Yes,
The um will be hydrochloric acid and sodium nitrate.
very good, excellent. It's option B. What do we get when we react hydrochloric acid with silver nitrate?
Hydrochloric acid silver. You get like